Hi everyone, I'm Yashi. I'll be talking about my work on understanding large-scale CMB anomalies using generalized non-minimal derivative coupling during inflation. Sorry for the big title. And this work is done in collaboration with Nilanjan Dev in the supervision of Dr. Rajiv Chan at IIC Bangalore. We all know that the present universe is well described by a 6-parameter lambda CDM model. And this model assumes an earliest phase of inflation, cosmological inflation, and this is something this epoch is something I'll be interested about in my work. So the Planck observes the CMB sky and it measures the anisotropies in CMB, which are of the order of microkelvin. And these anisotropies were seeded during the earliest inflationary epoch. And Planck precisely measures the power spectrum, CMB power spectrum. And of course, the lambda CDM model gives a nice fit to this power spectrum. Now, there are some anomalies in the power spectrum, which are some outliers data points, which are not yet explained by the standard lambda CDM model. So among many, I will be talking about one specific feature, which is on some large scales between multipoles 10 to 30, there is a dip in power. And I'll try to see that if some modifications in the standard dynamics can help understand the presence of these features. And during the inflationary epoch. Why during the inflationary epoch? Because this is the epoch where the anisotropies were first seeded during in the CMB. So the approach is to introduce some non-trivial coupling beyond the simple canonical single field setup. And the coupling is generalized non-minimal derivative coupling, where the inflaton is coupled to the Einstein tensor through a generalized coupling function, which is taken to be a function of theta. And these type of couplings are well motivated in the scalar tensor theories like Horndeski theories, and these give rise to second order equation of motion. So as a result of this non-trivial interaction, now the dynamics is modified, and you can have a glimpse of comparison with a simple canonical single field setup. And now the equations, the Friedmann equations and the Klein-Gordon equations do indeed depend on the functional form of the theta function, the coupling function. So this gives us some freedom to explore interesting dynamics. So this brings us to our exact model where we work with a positive theta function. Why this positive theta function? This is for a consistent theory. I would request you to refer to my work for the further details of it. And this function, we choose to have a dip-like feature whose amplitude, position, and width can be controlled. And because of this particular choice of the coupling function, now, there are specific features in the primordial power spectra. So on the left-hand side, there's the primordial power spectra from inflation for such a GNMDC model, where there are large-scale, there are oscillations on some large scales, and these oscillations decay and match the nearly scale invariant power spectrum on the CMB scales. Because there are features in the primordial spectra, these are also imprinted in the CMB power spectrum. And here on the right-hand side, I show the residual CMB power spectrum. And in the temperature power spectrum, one can see that around the multipoles 10 to 30, now the model can address some of these data points. So now for completeness, I do the data analysis and find the best fit parameter constraints and the improvement in terms of chi-square compared to the base lambda CDM model. Please again refer to my work for the details of these data analysis. And with this, I'll come to my conclusion slide that such type of non-trivial interaction, the GNMDC interaction, can indeed bring interesting implications in inflationary dynamics. And one such implication is what we have explored, like addressing large-scale features around 10 to 30. Now, we are also working on exploring other functional forms of this coupling function to address other interesting anomalies in the CMB power spectrum, like lensing anomaly, clock signals at small scales, and low quadruple anomaly. With this, I'll thank you all.
So thank you, Yashi. So thank you for your timely presentation.